So today we'll discuss the solutions to the PAVE paper. So first one is electric bell experiment. So the principle of electric bell is when current is flowing, it will act like a magnet, electromagnet. So if the switch is on and initially you say it's in contact, then circuit is complete, then current starts flowing. The moment current flows, according to an observer here, current is flowing in anti-clockwise direction. Then this will act like north pole because he will see that anti-clockwise direction will act like a north pole. Then the other end will be south pole. Now immediately when current is flowing, because it is a metal, current will flow through the metal into this wire. Now the permanent magnet should be repelled immediately. If it is repelled, then it will go away. Circuit is broke. Current no longer flows. Again it will fall back. It will hit it. When it falls back, it comes in contact. Circuit gets complete. Current is flowing. It will act like electromagnet. Again it will repel it. It will lose contact. Current stops. No longer magnet. No longer repulsion. Again it will fall back. So it will keep on going in front. That's how the electric bell basically work. For this to be working correctly, when it is an electromagnet, it has to repel the other magnet. So how to repel the other magnet? South and south will repel. So left side will act like south, then right side should act like north. So right side should be north pole. A is the correct answer for this. In question 2, when the multiple batteries are kept and connected through a copper wire, and then all the pencil leads are connected. Pencil lead is actually not made of lead. This particular experiment is basically actually made of graphite. This demonstrates that it's a good conductor of electricity, graphite. Current passes through it. It gets heated up. Now, if you put a burning paper inside the inverted glass, then that burning paper will consume some oxygen. So if the burning paper is put inside the inverted glass, that will consume the oxygen. Because the oxygen is consumed by the paper, which is burning, the lead will not get burnt. So because it doesn't get burned, it will glow for a long time. Otherwise, what will happen? It will rapidly burn. The lead will be rapidly burning and immediately it will break. And then it will stop glowing. Because it's not burning, it's a steady burn kind of thing. Steady flow of heat, due to which it's able to glow for a long time. So this experiment is a famous one, which you can try to see how this works. And you can understand the working behind this. Pencil lead bulbs work on the magnetic effect of current. No, this is not magnetic effect. It is heating effect of current. In actual incandescent, tungsten is used because it doesn't oxidize easily. Tungsten is used because main reason is it has high melting point. That is the reason. So the correct answer is only option B. Then third one, tungsten filament glows, but copper wires that connect the filament electricity doesn't glow because. So in question number 3, copper wire doesn't carry current. This option is definitely wrong because current will flow through the copper wire also and tungsten filament also. Even though same current is flowing through, tungsten gets heated more because it has low conductivity. Yes, low conductivity or high resistivity, because of which for same current, heat produced will be more, because heat produced greater the resistance, greater the amount of heat produced. So lower conductivity also means high resistivity, which is why this is the correct statement. All the heat is converted very quickly from copper to tungsten. Again, this has no meaning. Copper wire is connected to other part of the circuit, so it's cooled. Again, this is also not the correct thing. The main reason is same current is passing through the copper wire also, but this has high resistance. Since it has high resistance, for same current, more heat is produced. That is the physics behind this working. So fourth one, he is making an electromagnet. Now this is positive terminal. So current will flow in this direction. So according to him, it will come around like this. So for this observer, the current will seem to be flowing as clockwise. Since it's given anti-clockwise, this is wrong. If we replace iron by copper, it is not ferromagnetic. Only if you wind wire around iron nail, it will work. Otherwise, it will no longer be an electromagnet. So copper wire should be wound around iron nail. So iron is ferromagnetic, which is why it can act like a magnet. So if we replace iron nail with copper nail, it will no longer be an electromagnet. And then option D, if you take south pole of compass will point to the north pole, that is not correct. South pole will point towards south pole only. This is also wrong. Now, if you look at option C, end of the iron nail closer to the students will become like south pole. So when it is clockwise current, generally, so clockwise currents will tend to act like a south pole. That is the correct statement. When we touch a charging laptop, we get shock. This is because metal body of laptop is somehow connected to the charger wires and insulator layer is not effective. That is the correct statement. Charging adapter of fast chargers is providing extra current, so some of it goes to the body. That is not correct. There is connection between earth and laptop. If there is a connection between earth and laptop, current will go to the earth. It will not reach to our body. We won't get shock. So that is also not correct. Laptop is fully charged. Again, doesn't make. A is the correct answer. In sixth one, balloon partially filled with water doesn't burst immediately. But if it's filled with air, it immediately bursts. Because when you have water, some heat will be absorbed by the water also. So the balloon will not get heated up fast. So heat given to the balloon is going into heating the water. That is the correct statement. Air increases the heat conductivity of balloon. Again, other thing is wrong. Another thing is wrong. The first one is the concept for this question. Balloon hovercraft is made by sticking balloon to CD. Now, when you inflate the balloon and attach to the CD and then gently release it, the air will come out of it. So we have to choose the wrong option. Balloon pushes the air to flow via the disc surface, creating a thin layer of air between disc and the table. That is correct, meaning correct statement. This demonstrates that friction can be increased. Now, this means friction will be reduced. That's why it will now act like a hovercraft. Hovercraft means it will slowly be hovering above the table. It will move left and right and so on. Real hovercraft worked on same principle. Air comes out the balloon because air pressure inside is more. B is the wrong statement. Here friction is reduced. Because friction is reduced, it will act like a hovercraft. Eighth one, Ram is walking from his home to school every day. He starts from home at 8 and every day reaches the school 10 minutes before the bell rings. So here, what you can take is, like for question number 8, let Ram takes 8 minutes, X minutes to go from home to school. Then if you start at 8, he will reach at X minutes. But then it is saying that bell is he is reaching 10 minutes before the bell. So he reaches at 8 o'clock plus 8 X minutes. But bell is ringing 10 minutes. He is going 10 minutes before the bell rings. So he is reaching at 8 X means bell rings at X plus 10 minutes. So one day he got ready 15 minutes early and started for school. Which means 7:45 he is starting. 7:45 he starts because 15 minutes early. After traveling half the distance, he came back to the home and again went to school. Which means from home to school, he traveled half the distance. Now, if he takes X minutes to go from home to school, for half the distance, he will take X by 2 minutes, half the time. Again, he has to come back to home. Again, half the distance, so half the time. Again, he has to go to school. So instead of directly going from home to school, he went half the distance, he came back, again he went. Then he will take X minutes to go from home to school. So what is the total time he took? X by 2 for half the distance, X by 2 for half the distance, then full distance X. So time taken is X by 2 plus X by 2 plus X, 2X minutes. So 7:45 he started means plus 2X minutes only he'll reach. But he was 5 minutes late. So 7:45 plus 2, he is 5 minutes late means bell is ringing at what time? 7:45 plus 2X minutes. 5 minutes before itself bell rang. Now bell is ringing at 8 plus X plus 10 also. 7:45 plus 2X minus 5 also. Which means first we can convert 7:45 as, this 8 as 7:45 plus 15 minutes. That is 8 o'clock now. Plus X plus 10 minutes. Or bell ringing, we can now compare 7:45 plus X plus 25 minutes. So bell is ringing at 7:45 plus X plus 25. Bell is ringing at 7:45 plus 2X minus 5. Both are the same situation. So bell is ringing at the same time means 7:45 plus what is how many minutes? That has to be same. So X plus 25 is equal to 2X minus 5, or X is equal to 30. Then we need to find what time bell rings. So bell rings at 8 plus X plus 10. X is 30. So 8 plus 30 plus 10. 8:40 is when bell is ringing. That will be the method for. Now you think like 8:40 bell rings and you try to do this word play and see it will make sense. X minutes is his travel time. So X is the 30 minutes. 30 minutes is the travel time. So normally 8 o'clock if you do it, half an hour, 30 minutes he will take to travel. 8:30 he will reach. 10 minutes before the bell. 10 minutes before the bell. But one day he got ready 7:45 itself. You start for school. Half the distance if you go, it will take 15 minutes. 8 o'clock. Half the distance you go, it will take 15 minutes, 8:15. Again, full distance if you go, half an hour, 8:45 he'll reach. But 8:40 bell is ringing, so he is 5 minutes late. So that is matching with the, we have verified the solution. Then question number 9, 120 kilometer per hour. You have to convert that to 120 into 1 kilometer is 1000 meters. 1 hour is 60 minutes, which is 60 seconds. So 60 into 60, 3600 seconds. So 120 into 1000 by 3600. So we'll get this as 100 by 3 meter per second. This one is, second one is 100 by 3 means 33.33 meter per second. Horse is 30 meter per second. Bike is 1200 meter by 1 minute is 60 seconds. So 20 meter per second. So 20, 30, 33. Obviously the car is the fastest. Horse is the fastest is wrong. Bike is fastest is wrong. They are having different speeds. In question number 10. So car is traveling 300 meters with a speed of 10 meter per second. It is traveling 400 meter with speed of 20 meter per second. The car is starting from A to B. The distance traveled is 300 meters. The speed is 10 meter per second. Then time will be equal to distance by speed, 300 by 10, which is 30 seconds. Now 1, 1, 1. B to C, again it is traveling further 400 meters. So distance is 400 meters. Speed is 20 meter per second. Then time is distance by speed, 400 by 20, 20 seconds. Now they're asking what is average speed. Average speed is defined as total distance divided by total time. Total distance is S1 plus S2. Total time is T1 plus T2. S1 plus S2 is 300 meters plus 400 meters, 700 meters. T1 plus T2 is 30 seconds plus 20 seconds. So 700 by 50 or 70 by 5, 14 meter per second will be the answer. C will be the answer. And that's all in this paper.